How are you doing, guys? It's Emil here. Today we're gonna continue going on to calculating the U corrections, the Hubbard U corrections that is. This time we're doing it for the uranium F orbitals. In the last video we did the rhodium D orbitals. So I just went ahead and copied over these files here from the previous one, and obviously we're gonna do some adjustments. Not the K points, that's gonna be the same. The in-car is going to be the same, yes, yep. Good. So let's adjust numbers of core here. Let's do 6. We'll go to our job file, we'll do 36 cores here. Let's see, I believe we have to adjust the POSCAR, yes. So this time, right, again, we're not doing, the focus isn't on rhodium here, so we'll just leave that as such. We're going to add in another uranium, add 1, and this is going to be the 3. So that should be it for the POSCAR. Actually, let's double check. URhGe. So we're going to create our POSCAR file, URhGe. Yes, okay. And now we should have all of our files. I'm going to do sbatch job till f out, and we'll watch that as it goes. So now you can see our ground state calculation is all done here. The next step, again, is to do the NSCF step. And this is where I erred on a line of caution. I'll get into that in a minute. So again, you're going to copy the following from the ground state into each one where you're changing these two parameters. So you're adding I charge equals 11, all these. And again, I have a script for this. However, I have to get it. I have to find it. Okay, so we have make whatever. And then copy get, I believe, F values, yes. Okay, so let's view make NSCF1. Yes, so this is good, this is fine. Okay. So these parameters, it's gonna be the F orbital. So we're gonna do this to 3, and we're working on the first uranium compound. This is gonna be 3. This is gonna be set to -1. Just gonna add a 0 there. Move this one. I believe only 1 0 is needed anyways. So this looks alright. However, it does copy the entire in-car over, so you have to view the actual in-car and make sure everything's set before setting it. So again, when we add in the LDA+U, LMAXMIX is going to have to be set to 6 because we're working with uranium and particularly the F electrons. And number of cores is 6 here. We want it to be set to 3. We're going to use number of cores per node. Is that correct? Hold on. Okay. This is going to be set to 9. And now we should be all set. Let me just double check the in-car. Yep, everything looks good here. And then our job file, everything looks good. Let's double check our POSCAR. Yep. Make sure anything's in the foreground. No. Okay. And let's grab, oh. Okay, that should be good. So now I will make NSCF1H. And now we should have all of these set up. I will change into each of these directories, sbatch job. Let's tail the first one, and we'll see how it goes before we keep doing the rest. Okay, so we shouldn't have any problems here. Let's view the in-car again. Everything should be good. 3.3, yep. Good, okay. Everything should be good to go here. So now I will go back to each one in a particular order. Where were we? I think we're supposed to go to the negatives. Now we have a bunch of processes running, so 151.050 minus 05 minus 10. So that means one of them must be done, which is probably the one that we start off with. And that's it. There we go. And everything else is finishing up now. So we're all set here. We have all of them are done, as you could see. Let's see, where do I have to go? So let me change my directory backwards. Let's copy over URhGe, right? Let's do J0.51. It's gonna be here somewhere. There we go. CalcU. And then get F values. This one should be updated, I hope. Okay. Now let's view get F values. Okay. Goes to column 5, ion index 1. Let's just run it to see what happens. All right. So let's view the end of N0.15. Outcar. And we should see 3.139 for ion 1, which is going to be our uranium, and we see that's correct. So now I trust it. So these are what we get with the non-self-consistent fields. Now we're going to run, we're going to do our self-consistent field one, which is step 4. Copy all these over, remove iCharge11 from the in-car. And again, I have a script for this, really not that difficult. So let's make self-consistent field 2. Let us change the directory to N0.5 S. let us view the in-car. 3, yep, I charge 11 is gone. And again, these ones will take a little bit longer, the self-consistent field. Let's view the in-car. Oh, I already did that. Let's view the job, I should say. 9 cores each. Now let's start off with this. 0.10 S batch job. Let's double check that this actually works. We've car read successfully. Shouldn't be running into errors. Let's have it go through the first step here. Again, this is going to take a while, so there we go. Guess not. I stand corrected. Oop, Control C. Now let's do the same thing. 05 S batch job. 0 S batch job. Minus 05 now. S batch job. 10 S batch job. And finally 15 S batch job. So you can see we have all of them running. 15, 10, 05, 0, minus 05. You know, well, I mean, it would start from here, the 15, as the most recent calculation is listed up on top. It looks like we're going to hit job number 1000 today. So that's cool. So I will take a look at this, and I'll be back once we get the results. All of our calculations are done. Everything's converged pretty well, as you can see. I think that's the second time I said as you can see. So now we have all these total charges on the first uranium atom. Let's see. So again, a good, how do I say this? Check is that both your non-self-consistent and self-consistent are relatively the same. If they have, you know, the third, you know, the 100th value is different, then that's fine. Actually, 10th, 100th, 1000th, excuse me. So now it's just a matter of, you know, plotting it, calculating the slope, and whatever mathematical thing arises from it. So let's see if I have the notebook open. Where is it? Let's see. Where am I supposed to be actually? I have 2 desktops open. This is my monitor. Yeah, there we go. Okay. So I'm going to copy this over. Yeah. So minus 0.015. Actually, I think I could just erase all of it. So NSCF minus 0.015, we have 2.035 minus 010 and 2.188, 2.354, 480 minus 0.05, we have 2.482, 2.534. Okay, so that looks good. So again, you could just copy over this code because I don't believe the VASP tutorial does this really enough justice on the explanation. And there we go. So we have Hubbard U potential of 3.26 electron volts for the uranium F orbital. And I believe for the rhodium we had 3.12. And that's pretty much it. Now in the next video, I'll go over doing the standard non-collinear standard collinear optimization, and then we'll do the electronic structure, and then we'll move on to finally our non-collinear, spin orbit coupled aspect of this. So again, any questions as usual, feel free to send a message or an email, or just a comment down below. Thanks again for watching, guys. I'll see you in the next video.